A line integral adds up a quantity along a curve rather than along a straight interval on the x-axis. There are two kinds of line integral, a scalar line integral and a vector line integral. A scalar line integral adds up a function's values along the curve, weighted by a small piece of arc length written ds. In symbols, this is integral over c of f of x, y, ds equals integral from a to b of f of x of t, y of t, times the square root of, open bracket, dx by dt, close bracket, squared, plus, open bracket, dy by dt, close bracket, squared, dt. A vector line integral instead adds up how much a vector field points along the direction of the curve at each point. In symbols, this is integral over c of f dot dr equals integral from a to b of f of x of t, y of t, dot the vector dx by dt, dy by dt, dt. Picture the scalar case first. In the 2D view, the curve C sits flat in the xy plane. In the 3D view, above every point of the curve, we raise a vertical height equal to the function's value there, like a curtain hanging from the curve up to the surface. The scalar line integral is exactly the area of that curtain. Worked example, let the function be f of xy equals x plus y. Let the curve C be the upper half of the circle of radius 1, centered at the origin. Parameterize the curve with one variable, t, let x equal cosine t, let y equal sine t, let t run from 0 to pi. Differentiate the parameterization. Dx by dt equals negative sine t, dy by dt equals cosine t. Substitute these into the arc length piece. ds equals the square root of, open bracket, negative sine t, close bracket, squared, plus, open bracket, cosine t, close bracket, squared, dt. Negative sine t squared equals sine t squared, so this simplifies to the square root of sine squared t plus cosine squared t dt. That equals the square root of 1 dt, that is just dt. Substitute the parameterization into the function f of x of t, y of t equals cosine t plus sine t. The line integral becomes integral from 0 to pi of open bracket cosine t plus sine t close bracket dt. Integrate term by term. The integral of cosine t is sine t. The integral of sine t is negative cosine t. So the antiderivative is sin t minus cosine t, evaluated from 0 to pi. At the upper limit, t equals pi. Sine of pi is 0. Cosine of pi is negative 1. So this gives 0 minus negative 1. That equals 1. At the lower limit, t equals 0. Sine of 0 is 0. Cosine of 0 is 1, so this gives 0 minus 1, that equals negative 1. Subtract the lower value from the upper value, 1 minus negative 1 equals 2, so the line integral equals 2. Check step. Try a different valid parameterization of the same curve, using u equals pi minus t, so u also runs from 0 to pi, tracing the same semicircle. Carrying through the same substitution and integration with u gives the same antiderivative pattern. Evaluating at its endpoints again gives 2. Since two different valid parameterizations both give 2, the answer does not depend on which parameterization we chose. This confirms the line integral equals 2,